how is everybody doing? Looks like I'm sitting in the middle of your lunch and keeping you awake or energetic. So, I think same topic, similar topic, but so I was thinking when I looked at what I'm going to talk about, it's similar topic what Sunit talked earlier, and however, we wanted to go in detail. So what better way I thought could be than to look at and use ChatGPT to ask some questions. So that's what I did. So I asked 3 questions to ChatGPT. First one, I asked it I wanted to find out some jokes around it. So what do you call data engineering project managed by Gen AI? And ChatGPT by OpenAI came back, told me it's a pipeline dream. So looks like they still don't think we can have a pipeline for data engineering using Gen AI. My second question, what do you call Gen AI role in data engineering? So what's the role? So it says Chief Data Imagination Officer. So keep imagining things, what's going to happen in this space. Third one, I asked them about what do you call generative AI on data engineering? So it came back with saying synthetic data magician. Okay? So we're going to talk about this synthetic data magician today, how we can use this magic using our chief data imagination officer's imagination to really think about this pipeline. Okay? So three components to it. The first one is, of course, Gen AI. We'll see. I don't have to explain what Gen AI is. However, we will talk about when we looked at Gen AI and when we looked at certain patterns, what patterns really make sense, especially from financial services industry perspective. I come from Morgan Stanley. Been in the financial domain for many years, more than 20 years, so really looking from that perspective. The second component is really data. So we all know data, structured data. All data pipelines today are based on structured data. We store many databases, data warehouse, data lake, and now we're getting on the cloud with different cloud providers that we have available. And third portion is really the engineering aspect of it. So let's just jump into it quickly, okay? So Gen AI, everybody knows what Gen AI is, machine learning models, so I'm not going to talk about that. However, one thing to note is Gen AI, machine learning or neural network deep learning models that we have, it's a next stage of automation from where we started with, let's say, RPA, then machine learning models itself from predicting perspective, feedback loop. Gen AI is, I will generate it for you. And when it generates for you, it doesn't stop, it keeps generating. So what data you feed in becomes very critical in terms of the quality of that data, in terms of the correctness of that data, in terms of the detailedness of all that data. So that's important. What I want you to look at is, what we looked at is these 6 patterns that comes up. So information extraction works pretty well. So you have a lot of documents, you can extract information from it. Information explanation, summarization, pretty good. We have our LLM models today, which really works very on a generic data set, which is unstructured data. It works pretty well in terms of summarization of that. I will go translation from languages. Very good. We have seen many implementations of it, and we also do that in our implementation, translating the language from Spanish to English. We have international customers, so it works pretty well from perspective of their contract and things like those. Questions answer, retrieval, Q&A. Very good in terms of, and you can implement Q&A features at various different stages, different applications, and we'll talk about it. Predictions, analytical inferences or information correlation between multiple areas, multiple docs, multiple data sets that you have. And then I'll go to the code generation aspect of it. So you can generate code, you can pretty much create even the documentation of your code, and then recreate code into different languages. So we'll talk a little bit about that. And the reasoning and action. This is where your structured and unstructured data marries and comes together. So you do reasoning based on Q&A, and you marry that with your structured data to take the action, where you can have either human take the action, or you can take it further to have your system itself take that next action. So let's talk about the second component of it, which is data. I kind of touched upon it. Typically, all our systems, if you look at here, on financial services side, CRM, sales, financials, client portfolios, trading system, order entry system, capital markets, everything is structured data. We store them, different databases. Some of them also uses MongoDB and things like those. However, mostly stored in relational databases if you go traditionally, and then that gets into your data warehouse, and then you have analytics on top of it. The second portion of this is unstructured data. So think about sales to service. So think about this, I'm supporting all my clients, I'm supporting all my financial clients, as well as my internal financial advisors per se, who are using systems, and they are generating all this data. The second thing is, which is the unstructured part of it, think about the contact center applications, where agent is dealing with the users, dealing with the clients, dealing with financial advisors, internal as well as external, or even your internal desk about technology support, right? It could be anything. And what do? You have call logs, you have videos, you have manuals, you have text. When I go into the area of research that Morgan Stanley provides, we have tons of documents from research perspective that we use. Everything is in data, right? And that data is not tapped. So what Gen AI is doing is helping tap that data. Now, when we looked at those 8 patterns on the previous slide, over there, if you look at them, they translate into these 5 areas. Content generation, and we'll talk about that, where we can do that. Summarization, very simple. That's the second use case. Translation and transformation of that data. Information retrieval, Q&A on the data. And 5th one is task execution. So that's kind of our focus from financial industry perspective, where we are looking at. One thing you have to realize, I don't know how many from BFSI over here, or how many from the firm, from startups who want to get into fintech and things like those. Anybody? Okay, I see a few hands. So one thing you have to understand is banking and financials, very highly regulated industry. And anything you do with the models, even your machine learning models, you have to explain how it works, what it produces, what advice you are giving, and how you're executing on it. With machine learning to AI, or Gen AI specifically, most of the models which are working there, which typically in the industry are making names, they are closed. There are open models, of course. So now open versus closed. So if you have a closed model, how do you explain it? You can't explain it. So it's a black box for you. And that's where the tricky thing will happen with the financial services industry perspective, as to how do you implement certain generic models versus how do you go into specific models, and then explain that, have the regulatory aspect, which are very different from country to country perspective, and take that forward. So that's another area to look at. Let's take a look at typical data engineering pipeline that we work with. And of course, there is a whole lot other than what I have put here. Requirements gathering. If you think from the perspective of who all are included as part of that, when you do requirements gathering from data point of view, you have your business owners, you have your product owners, you have your data scientists, you have your engineers, everybody touches here. Various different types of assessments are done, documents are created, designs are created at various levels, and you store them either PDF, Word document, Jive, repositories, different places. Business stores it differently, technology stores it differently. It's not at one place. It's at 100 places, 50 different places, right? Governance-related aspects, the data sources documentation, where the source is coming from for that particular. Is it from the file systems? Is it from your databases? Is it from lake? Is it from warehouse? Multiple different things. So many data points. The second area you talk about ingestion of that data, when you feed that data into your lake, and during ingestion, you do look at the quality of the data. You do look at the source type of the data. You do look at the various assessment from sensitive data perspective, masking perspective that you need to do. And you heard about that in the previous session, so I'm not going to go detail into all of that. Partitioning and monitoring, logging data, all of that gets into your warehouse. And it's sitting there, right? Third process, typically what we do, either ETL or ELT. You extract, transform, and load, or you extract, load, and then transform if you want to use it. So that's our typical pipeline. So that talks about data enrichment, data logic, that we create, specific tables we create. So you are replicating data further, pretty much. After extracting, transforming, loading, you are curating it, and before distributing, making sure that what the system needs, applications need, you're going to create those and send them over to there, right? And I'll go into testing a little bit later and workflows, orchestration, but that's what happened. And then you distribute it to applications which want to use it. It could be visualization, direct showing of the reports. It could be further analytics on top of it, AI and ML, to get the insights from it. For example, let's say we do fraud detection, for example. So from fraud detection perspective, you're going to look at a lot of data set and see where the patterns are, where the workflow is changing, what is happening, and is that check which is deposited, is it a fraudulent check? And identify that ahead of time. So you distribute that, and then your applications use it, right? So application usage, we talked about visualization, as well as you could do experimentation. There are sandboxes that many firms have that business uses and works on, to data scientist uses to find out. Now let's take all of this and try to put that into perspective in terms of our topic, like Gen AI's role in data engineering. So you see, there are tremendous activities which are going on, and I can bloat that each one into 10 different things that we do as data engineers. So let's look at where you can implement it. So when I look at it, yes, you can generate requirements, yes, you can collate them, all of that, but the bang for the buck is in the three areas, which is your processing, then distribution, and really using it for your AIML pipelines. If you look at each one of them, I highlighted some, so we'll talk about it. Let's say code assistant. I could build a model, and using that model, I could generate the code from it, right? We talked about first step. We have a lot of legacy systems. If you go into financial services domain, most of these firms are years old, and their systems are legacy, old code. Many of them still use mainframe, believe it or not, even if they may be on cloud. They still have those mainframe systems somewhere. So how do you extract? And there is no documentation of it, right? So you could generate the model, and you could build the documentation from your code. So it's a reverse engineering. Take the reverse engineering, and then you build a model to really write code in your chosen language, whether C++, whether Java, whether it's .NET, whichever, you know. So you could do that, and that gives you a bang for the buck from the efficiency perspective, and that's what we do. It also reduces effort of developer who in today's world Google it, find the code, copy paste it, optimize it, and use it. Instead of that, you can train your model further to use your code base, your internal frameworks in terms of generating the right code. So now what we are talking about is a generic Gen AI model, taking those models but customizing it to your needs. And you do that by feeding in your data sets to it, okay? Still using the same black box model. And we'll talk about how we can do it, how this pipeline can change, okay? Lineage. One of the biggest concerns or challenges is getting the right lineage, creating the metadata of it. There are tools available. However, I'll tell you, those tools are over there, but when you apply it to the business functions and logic, there are challenges. So I'll give you one example. Let's say if I have to calculate assets under management at the firm level. Let's say I have to calculate asset under management for different businesses that firm may be doing. For example, if I take financial services, I could have wealth management, I may have investment, asset management business, and other areas. So what's my asset under management? And there are multiple systems which are working towards it. The data sets are pretty distributed. When you bring all of that together, it has to make sense out of it. And then I need that on a daily basis, and I need that weekly basis, monthly basis, quarterly basis, annually basis. So now there are programs which are running, which are doing this AUM calculation at various levels for me to get that historical data and do the right calculation. And one thing you should realize, the transaction that you do, the trade doesn't settle on the same day, right? So the trade settlement happens later, and then there are changes to it. So if you take that example, Gen AI really helps in solving a lot of that. When we apply, how do I find AUM by using RAG techniques and other things, you know? So we do some of that. If you go on, and I can talk about each one of them, but I'll quickly go like search. You could do if in today's world, if I have to do discovery of data, tedious process, I could write very easily having a pinpointed search using Gen AI models built on this. It works pretty well when you are feeding the data. The third thing is feature cataloging. So I think let's talk about this, feature store and feature cataloging. So AUM, I gave you example. I can create this as a feature. So what I'm calculating is AUM. Then I'm storing that as a feature store, saying that I have an AUM feature being developed. I have a code written in Python which is writing, which is running. I have data for it. Now I support my data, which is the documents or the requirements to it, and I feed that into my Gen AI model, saying that, look, you already have AUM calculation. Using that, using this requirement, generate all this for me. And it's a flip of thing. So I have almost like so much efficiency in it. I don't need to do any coding, nothing, right? So one of the examples. I can probably go on many of those. So creation of feature store itself. You can utilize your models based on inference as well as based on RAG to create your store of your feature, create a catalog of it, saying that I have all these features, and store it. And then further, when you have a requirement coming, your model of search that you're doing using Gen AI will allow you to pinpoint, saying that, hey, you have this feature, or it could infer and find out correlation between multiple stores or features that you have stored, and come back with some of the guidance. So now your analysis is improved. If you have to do it manually, you're going to spend days and days. Here, it's going to happen in maybe hours. We have all the data, you study that and move forward. So efficiency gain there too. Synthetic data generation, I mean, in prior session also we talked about it. We generate data. This is very important and valuable in QA data generation, I would say. In financial world, you have so many types of accounts, and you have so many variations of different type of data that people may have. Somebody may be high net worth, ultra high net worth, having millions of dollars, millions of rupees, and then somebody may have mass affluent, somebody getting into self-directed, very small number. So your data behaves very differently when you feed into those same models of AI. Forget about Gen AI, the regular AI ML models, the regular ML models that we have. With those, now it's absolutely impossible for any firm to run all QA cases with the data variation, because you have literally millions and millions of variations and combinations. And firms struggle to have that level of data in their QA environments where they can do all this testing fully. One of the use case. So you can use Gen AI models for synthesizing that data, feeding in the requirements. Based on that, you create all this synthetic data, which will help you to regression test, PE test, functional test, end-to-end, all of that. Huge benefit of it. Visual designs, it's simple. You have different visual designs. You can customize that, feed that data of your UIs or reports, your style sheets to Gen AI model, and it will infer that and give you a newly created version for any new reports that you may be generating. Okay? So just see the efficiency again that comes up. And NLP-based feature search, nobody needs to code anything for it. You work on your prompts, and based on your prompts, master it. Very low level of coding needed. Based on your prompts, you use the NLP-based feature generation, search generation through your chatbots. Okay, so I'll quickly move to the next one. So we talked about various use cases where you can implement. So pretty much in every step of your data engineering pipeline step, you could have AI-based model gain efficiency for you. However, you can't really do that with the current pipeline the way it is, which is your ETLs, extract it, run it. The moment you bring in Gen AI, you got to chunk it out. You got to create embeddings of it, create the vectors of it. You need to have those vectors stored. Your vector store will need to have search on it. The further you take it, you have to have index. You load those. The vectors are created based on embeddings and chunking. So how do you chunk it? How much should be a chunk? That in itself is one big engineering area from chunking perspective. And that goes based on the use cases for your business. Depending on your use case, your chunking could be a small chunks or larger chunks. Then you need to have ability to put those all vectors back and give the output. So to do this, your current data engineering pipeline will not suffice. So what you need to do, all your data which is coming in, this is like today. If it's coming in bulk, you may have NAS storage where data may be going. If you want to do real-time or streaming, you could use Kafka queues or stream there. You stage it into your different databases, whether it's on cloud or on-prem, depending on your needs. And then you create ADLS, your object stores. This is kind of same what we do today. Many companies have that architecture. But when you go here, now you have generative AI models. So these models, depending on what your need is, You're going to go whichever model. Let's say you go OpenAI or you go Llama. Depending on your need, you're going to have those services for your embeddings, for your inferences, for your RAG and all of those, right, techniques that you use. When you do that, you need to have ability to provide almost this as software as a service. Because you are not changing models there. You are not fine-tuning models. You are just using it. So if you build it software as a service, anybody within your firms or your clients could use it. You can offer it that way. When it goes to vector management, now you have to chunk it and create those vectors so that it can process those models. So you store the vectors into your choice of database, right? I'm not going to recommend anything. There are many vector databases that you can use, right? Whether you store it in Redis, whether you store it in Mongo, whether you store it in Solar, depending on your need, your choice, you store it, you index it, and now you are dealing with those vectors. However, you also take it further, create the catalog of that vector itself. So next time, when I'm getting a requirement which touches one of the areas that I chunked, you know that I have a vector already created for it. So now your software is really looking at that and reusing those vectors, and you are removing the duplication of the data, which you would do in your ETL process many times, because it's very customized to your needs right now, the implementations the way they are in the industry. Using this, you can use this as a platform as a service. So you decide on which vector database, you decide on which cloud-based or on-prem solution you are giving. You can create your platforms. Platform provides all these APIs, and you could decouple that to provide that for your software. You keep your application layer separate. The application layer has the ability and freedom to create the vectors that they need, because that's where the requirements are coming from. However, those vectors are fed through this vector manager, where all of your logic with respect to do I need to create or reuse goes in. So if you scale this further, then your data engineering complete pipeline is changed now. You're not doing ETL. You need to have the ability to do vector management. You need to have the ability to find out what works well, what I offer as infrastructure as a service, what I offer as platform as a service, and then what I offer as software as a service. With that, you will be able to reuse and do your application tier, which is called here as analytics AIML, where either the data is coming from your vector databases, or it's coming from directly as a model that you're using. Now, one last thing out of it, I will say, is the models are still getting better and better. If I go to Hugging Face, I see hundreds of models coming every single day. So we literally have thousands of models. Where we are heading is really which model is best for which features, what we are generating. We talked about small language models earlier, but I would say it's more than that. It's really the applicability of your model to the business case which needs it. So you're not going to implement GenAI for every single thing. You have to have that ability to identify where should I implement GenAI or AI-specific models where it makes sense, and then take it further. So with that, I think I will stop because I can go as much deeper into it in different areas. I don't know how much time we have. 1 minute? Okay, so we'll do Q&A if anybody has any question. So you get the idea, right? So it's a two sides of same coin. You can't say that I'm going to do data engineering and implement GenAI for it without changing your data engineering pipeline and having the ability to do all of these stuff.